central process unit of the system is Raspberry Pi 3 embedded computer. Besides, our system also use Arduino board to communicate with the other device like buzzer, button, and relay. So now we will move to the experiment. The first thing I show you our dataset. We obtained from 100 healthy participants in the daytime. The participants over 18 years old, wearing and not wearing glasses. The next one, implementation details. So we divided dataset into three subsets. The first one, training set, and validation set, and test set. And we train the network for the 100 people. And we use the NVIDIA GeForce GTX 1080 Ti CPU for the training. So this is the result of my papers. According to table 1, the model could predict the rival Rossinus state with compute accuracy approximately 94%. And we can see the accuracy and loss curve of the robot LSTM network architecture like this one and this one. And let's look at some quality results. The left figure and the right figure so that visual result of the non-Rousey and Rousey detection previously. So the first round sleep design detection result in the frontal view, and the second round and third round illustrate the detection result of the hit point angle of setting left, right, and left. And the last round exhibit the detection result of the hit point angle of the knocking. With computing accuracy suggest that our research has the potential for practical application. According to table 2, we also conduct comparison to existing methods. We can see my work achieve the accuracy better than the other one. And finally, I want to quickly summarize my paper. We want to introduce a dataset improve the robust performance of the deep learning by Rousey detection methods. And the second one, the model could predict the rival Rousey state with computing accuracy named approximately 94%. And finally, our system will build on the versatile and affordable hardware platform. So in the future, we want to integrate the learning behavior driver into the model with addition of the achieved surpassing result. And I also want to improve the my system working at the night time. So this is the my presentation. Thank you for your listening. If you have any question, we move to the discussion session. Thank you.
Thank you, Mr. Thiện.
Yeah.
I have. Do you have any question for audience? In the waiting time, I have one question for you.
Yeah.
So when the driver get into the car, how long does it take to for the training?
So you mean ask me the model training how many times?
No.
Right.
When the driver get into the car and start to drive.
Yeah.
So how long does it take for your system to train so that it can take effect.
I see. My system either training first, and I will we will install the system in the car when the driver get the car, and the system automatically detect the routing state.
Okay, so you have to train first. Okay.
Yeah, yes.
Okay, and second, nowadays for the COVID pandemic, a lot of people were wearing masks or some glass to avoid the spread of the virus. So can if you can take that into account, I think it will be the good thing.
Yes. I thank you for your recommendation. So, but my system not yet consider when the people wear the mask, but my system only focus the data set with the wearing glasses and without glasses. I not yet focus on the face wear the face mask.
Okay, thank you.
Yeah, thank you, Professor.
It's interesting.
Yeah.
May I have some question? I'm sorry, may I have a question to Mr. Thiện?
Yeah, Professor Dung.
Okay, so in your system, the detection is fit for all people. So actually, do you consider about the driver they wear glasses?
Yeah.
For example, I have sunglasses or something like that. It should be different to detect crossing this driver.
Yeah.
So, did you consider to solve that problem?
As I mentioned before, I just focus on the without glasses, and I don't know say about that. Not black glasses, you know.
Okay.
Just white glasses. I just forgot on two case. Yeah.
Okay. So, do you see about eyes? Sometimes it's different. For example, my eye is quite wide. However, other is very narrow. So maybe sometimes it's different, right?
Yeah.
Okay. Okay. Thanks for your contribution.
Yeah. And thank you, Robert.
I have one question.
Yes, please.
Okay. Please go to the page 13. Page 13. Okay. In here, you have the comparison of your approach. Okay.
Yes.
So your approach is much better for the accuracy. However, did you compare the calculated time? Maybe in your approach, you need to take a lot of calculating burden.
Yeah.
So do you compare the calculating time?
Yes, I have. So I not yet compare in term processing time. I just compare the term accuracy. So in the future, I will compare term processing time later.
So how long were you using? How long were you use algorithms in computer? How long? How long will you take?
I trained my network approximately 2 hours.
2 hours. Okay, yes. I see. Okay. Thank you.
Yes, thank you, Professor.
So is there any further question? Okay, thank you for your presentation and the answer. Okay, thank you.
Yeah, thank you, Professor, and thank you, everyone.
Okay. So let's come back to the first round. Let's welcome the third presentation, paper number 22. The title is A Deep Reinforcement Learning Model Using Long Context for Chatbots. Is there any author of paper number 22?
Professor, my paper is I'm a third person.
Okay. Okay, please start your presentation. Thank you.
Yes, yes. Can you see my screen?
Yeah, we can see it.
Yeah, thank you, Professor. Good afternoon, everyone. Let me introduce myself. My name is Quốc Đại. I'm a member of NLP Lab in TTU. Today, I'm going to talk about my topic, Deep Reinforcement Learning Model using long context for chatbots. My presentation is divided into 3 parts. Firstly, I talk about definition problems and challenge of problem. Second, I will talk these models and components which I use in my research. Finally, I will present about dataset, experiment, and my result. First, as on a chatbot is a computer program that can simulate conversation and interact with humans. They can generate text utterance in response to an input utterance. They can also provide information for user. They can help user do some tasks or answer questions from user. Now I would like to move on to a challenge in chatbot system. Most of the techniques for dialogue system utilize the research in machine translation, but there are differences between translation system and chatbot. Translation system usually has one-to-one mapping between each word in the source and the target sentence, where the dialogue system can have multiple possible response to the same input. And recently, many models were trained by using neural network. The sequence-to-sequence model is widely used in neural machine translation, and these models have also achieved success in chatbot system. Sequence-to-sequence model consists of 2 recurrent neural network, an encoder-decoder neural framework that maps variable length input sequence to a variable length output sequence. Decoder can map variable length source sequence to a bit length vector, and decoder will map the vector representation back to the variable length target sequence output. So the current neural network are trained solely to maximize the conditional probability of the target sequence with given a source utterance. One of the advantages is most of these models aim to improve the content quality of conversation agents. Another, these models are able to generate more meaningful dialogue response without facing the deviant models. Most of the models only generate the best response from a single utterance, but this method is only suitable for single-turn conversation system. So in a multi-turn conversation, sequence-to-sequence is still short-sighted in predicting response on at the time while ignoring their influence on future outcomes. I will show an example define the success of sequence-to-sequence models in dialogue generation. There are some problems. Firstly, this model tend to generate highly generic response. One example is that sequence-to-sequence tend to generate the generic response such as I don't know, regardless of the input. This is due to this response found in the training set have a high frequency. And another common problem is that the system with the more sequence-to-sequence model becomes stuck in an infinite loop of repetitive response. We can look in at the entire conversation pattern turn out to be bad action and to such because it offers no way to continue the conversation. So the conversation will become too stuck. In rapid, human conversation usually consists of one turn. In a table, we show example. There is a conversation example between a son and his father. In the conversation, the answer at turn 7 is not only based on the previous turn, but also use the information bursts which were mentioned at an earlier turn. In turn 3. So a good conversation system is required to be able to manage the flow of information and connect the turn and TT event in long conversation. So to resolve a problem, we interacted reinforcement learning technique into the sequence-to-sequence model. Reinforcement learning were designed to resolve problems in which a sequence of decision in it, and it used reward to evaluate results of generative models. We can define a conversation as a Markov decision process. Corresponding Markov decision process is the following. Setup state is defined for the conversation history. A state is denoted by the two consecutive conversation turn. And setup action is set up possible sentence or system to reply the user. The third factor, policy were built by updating the history of the conversation after adding the last sentence, which were generated by the system or the user. And we build the policy by the long short-term memory decoder. The final factor reward function is a forward-looking function that we know the reward obtained for the action. We also show an example how to define a conversation by the Markov decision process. The state is defined as history of conversation, and the action is generated by long short-term memory. We will add the new action to history and update the new state for the reinforcement learning. Our system is divided into two main components. The first is dialogue simulation, and the second is the reward function. And we use policy guidance method to reward sequence that display to use full conversation property. This is my dialogue simulation. At the first step, response were generated from the input sentence by the response generation module, and the response generation module were built by the long short-term memory. And then the second agent or the turn to update the state by adding the last sentence from the first agent into the history of dialogue and use the long short-term memory to generate the new response. They are subsequently feedback to the first agent and the row sheet is repeated. In this session, we introduce our two reward function for the two desirable goals. For each agent to contribute new information at each turn to keep the dialogue moving and avoid infinite loop. We also check the semantic similarity between consecutive turns from the same agent. And the second reward, we also resend this reward would help the model learn semantically meaningful representation for word from the sentence. We use the cosine function for this reward. And about the dataset, we use for my experiment, we use the daily dialogue dataset. It has more 13,000 multi-turn dialogue, and there are three large categories in Latin relationship, or the now reply and word. Each dataset were built by human. And for the purpose of comparison, my hyperparameter of the robots, my models set the same as the pipeline model. Detail the encoder and decoder have long shorter memory structure. We also set the path size as the 64 and use Adam optimizer. On expression, the vocabulary size is set the 25,000, and on the out of vocabulary words are mapped to the special token. This is an announced token. And we also set word embedding better to size 300. In our result, the goal of our system is not only to predict the highest probability response, but we also take care of the long-term success of the dialogue. Therefore, we use the coherence score beside the blur score for evaluation. We find that the my robots, the reinforcement learning models, can generate more coherent output than the baseline model. In additional, our model improved up 43 average blur score compared to the baseline. And this is the end of my conversation. Thank you for your attention.
Okay, thank you for your presentation. Is there any question? I have two questions. Please go to the page 15.
Yes.
Okay, here, is it possible for the reward, the value of the denominator is equal to 0? That is, it's possible for the norm of HP is equal to 0.
Oh, yeah, Professor. We use the mutual information between the action A and B conversation in dialogue, and we will ignoring the action which must the 0 in the formula. And we use the blur score to ignoring the answer. We'll match the formula with the 0.
Okay, I see. Okay, please go to the page 18.
Yes.
Okay, so could you tell us how to determine the hyperparameters? How to determine it?
Sorry, Professor. I cannot understand your question.
Okay, you have the values of hyperparameters, right? For example, yes. You have 1,024 hidden cells, and you have the learning rate equal to 0.0 001. So
Yes.
how to determine it? How to determine your values of the hyperparameters?
This is we use the parameter. We experiment on the 3 parameter, and we choose with the best parameter, and so we also use the result of the reviewed paper. Yeah.
So how to guarantee these parameters are optimum, are the best? How to guarantee?
So we set the high parameter the same between the micro model with the baseline model, and the same with the reviewed paper, reviewed order research.
So is it possible to choose another group of hypermeters and better than your results? Is it possible?
Yeah, I think it is impossible.
Okay, thank you for your answer.
Yes,
Is there
thank you,
any
thank you
further
very much.
question? Yeah, please.
Yeah, I have a question. Yeah.
Yes.
Yeah, please.
In the deep reinforcement learning, I see in your application, do you this kind of algorithm value-based learning or policy gradient learning?
We use the policy gradient method.
Why you not use the value-based or the value-based learning or something?
So I improve this research from paper reviewed paper, and we have experiment the value pay for the reinforcement learning, but we see we find that the policy gradient method is better than the value pay. Yeah. So and many the chatbot system were built by the reinforcement learning. Many research use the policy gradient method.
Okay, thanks.
Thank you.
Okay, is there any further questions? Okay, no, okay. Thank you for your presentation and the answer. Okay.
Thank you, Professor. Thank you, everyone.
Thank you.
And the first round presentation is over. Let's welcome Professor Chen to chair the second round presentation.
Okay,
Professor
thank you.
Chen, please.
Yeah, thank you, Professor Zhu. Now we are moving to the second round. So the first paper for the second round is the paper number 23. Multi-view transformation for recommender systems. 23. Please. Yes.
Good afternoon, Chair. Do you?
Yes, good.
Yeah. Do you your my screen?
Yes, I see. I see.
Yeah.
Good afternoon, Chair and everybody. My name is Thị Lên Hồ. I come from Bandicam University of Ho Chi Minh City and LIP Lab of Tôn Đức Thắng University. Today, sorry, Today I will present my topic multi-view transformation in recommender system. Nowadays, a customer can review about service or products under main reviews such as rating score, comments, emotion icons, so on. My topic is related to using information of comments for balancing rating score. My recent has one session include problem statement, challenge, background, methods, experiments, result, and conclusion. Today, customers often comment about service or products after review, but the review among users may differ even though their feeling about product or service are similar. Example, both customer A and customer B had the same good feeling about service review. However, the customer A rated 4 points, but the customer B rated 5 points. If we use those rating scores for the recommender systems, the accuracy of the recommender system can be decreased. The challenges are both that we need shown. The first, we robot a transformation model which uses the summaries of that reviews to calculate the review score. We use the review score to transform on user current ratings into new rating for balancing the ratings among users. Then apply for recommender systems. Then the second, we need to evaluate the performance of the robot model. Continue. You can see the basic theory of recommender system. Sentiment analysis or opinion mining is an active area of study in the field of natural language processing that analyze people opinion, sentiment, evaluation, attitude, and emotion via the computational treatment of suggestivity in text. In our study, we use two sentiment analysis tools, VADR and Affin. VADR sentiment analysis tool gives us score of low in category positive, negative, neutral, and combo. Affin sentiment analysis tool contains more than 3,300 words with a quality score associated with each word. You can see in my slide a sample of utility metrics which present user rating for items. For content-based recommender system, we need to build feature vector for each item based on the movie zones matrix and feature TFD IDF, and they were denoted by I1, I2, I3, so on, IN. The problem of finding model theta I for each user. A training dataset for building each model theta I, a pair includes item profile rating corresponding to item that the user rated. You can see example on this line. A couple include item profile and user rating. If we want to read the rating that a user U raise an item I, we can apply model theta I. So briefly, steps to build a content-based recommender system include need to build a profile for each item mathematically presented as a feature vector xi and adjusted from the item's properties. A utility matrix y with dimension n by m, where n is number of user, m is number of items, emitting many components that component to values that the system needs to predict. Ij is the degree of reference of the user has order I for the item has the order j that the system has collected. For each user I needs to find a corresponding model theta I, example heuristic regression model. For user-based recommender system, we need to determine user who have the similarity to the target user using the rating of item that two user correlated. You can see example on this slide. Two user Tom and Mary. And two user Mary and Peter. If we want to predict the rating that a target user U raise an item J, we can use the similarity of user V in a set of K nearest neighbors of the user U and ratings of users V for the item G. The formula for Pearson correlation similarity given below is used to compute the similarity between the row of rating matrix to find out similar users. Formula to estimate the rating of target user U to item J is given by, you can see two formula in this line, where KNN is a set of K nearest neighbor of user U. RVJ is the rating of user V on item J. R by U and R by V mention the average rating of user U and V. Sim U V refers to the similarity between user U and V. For item-based recommender system, we had to determine a set of items that the highest similarity to target item J using rating that users correlated both two items based on number of users ratings of item. You can see example in this slide. When we want to predict the rating that a target user U raise an item J, we can use the similarity of item I in the set of K most similarity items to item J and ratings of user U for items I. When the Cousin similarity technique use the inverse item frequency, the formula to compute the similarity between item I and J is given by, you can see the formula on this slide, where UI and UJ refers to a set of users who rated items I and J respectively. IUI is ratings of user U on item G on item I. I user U and RU RUZ is rating of user U on item J. The function log n fu refers to the inverse item frequency of a user, where n is the total number of items in the system, and FU is the number of items rated by user U. The formula to estimate the rating of target user U for target item J, you can see the formula on this slide, where MSI is the set of k most similar items to item to item J. Sim Ij show a similarity between items I and J. In our proper model, we use sentiment analysis tool to score summary comment. Then we give this review score and rating score into the transformation model. Output of this model is input for the recommender system. You can see the formula to transform rating score on this slide, where rating score denotes the rating score after transform means Vader score denotes the Vader scores, alpha denotes the exponential value, F score denotes the affine score. With this experiments on a mini dataset from Amazon's cell phones and accessories dataset, it has two data file, review and meta. Dataset include 10,000 user and 1,050 phone and accessory. You can see detail of dataset in this slide. Item-based or use-based recommender system needs to find k-nearest neighbors to get information for the target user or item to perform the task of registering the user level of reference in the items. Applying a transformation algorithm based on score that is computed, user command will help balance the user ratings. So the users or items k-nearest will change after the transformation algorithm is applied. You can see the table 2 on this slide. The table 2 shows that the list of k-nearest neighbors of the user having index 9 is chance applied in the transformation algorithm with Vader and or affine sentiment analysis tool. You can see has top 10 neighbors of a user having index 9. The table 3 you can see on this slide show that the list of phone and or accessory recommended for a user having index 9 by different individual recommender systems, such as content-based, item-based, or use-based. You can see the result on this slide. Vary in item and recommended order. For example, top 10 phone or an accessory recommended for a user with index 7 and a user with index 14 has the different order. You can see 14 item 14 or 7. The first row you can see the order of items which are recommended for a user having index 9. Conclusion, we robot a transformation algorithm in recommender system which transform the rating score collected by the system corresponding to either composed score or affine score. Then we use the transform rating score in the different individual models of recommender systems. The results show that our transformation algorithm helps to balance rating score, use them for prediction tasks in recommender system, and recommend items that are close to user needs. This is a suggestion for further study in finding out transformation algorithm to improve the efficiency of recommender system. Thank you for listening.
Thank you very much for your presentation. Are there any questions for the presenter? Is there any question? In waiting for the question, I have a small question for you. What language, what tool are you did you use to calculate your result?
I use Vader analysis tool, sentiment analysis tool Vader, and affine two sentiment analysis tool.
And why did you use the data from Amazon, right?
Because
why do you choose that data?
Because I see on many study everyone use Amazon to do experiment in their study, and
yes.
Yeah.
Thank you. Is there any questions? Okay, if not, so thank you very much for your presentation.
Thank you, Jay, and everybody for listening my presentation.
Yes. Okay, now we are moving to the next paper. The paper 29.
Yes, the paper 29 is presented.
Okay, thank you. Go ahead, yes.
So can you see my screen?
Yes, yes.
Okay, so firstly, my name is Hung Bình, the presenter of the paper 2080 ID 29, undergraduate of University of Technology and Education. I'm here today for a conference and discuss about a problem, the high performance speech recognition method based on a nonlinear neural network. So we're going through the content of the presentation. The first part is introduction to speech recognition model. Second part is speech signal analysis. The third part is advanced model of neural network. And the last part with examination and result. So we're going through the first part is introduction to speech recognition model. So what is SR system? Is important technology to enable an improvement human to human and human to computer interaction. It's a process of decoding the acoustic speech signal capturing by microphone or telephone, or understanding of voice by computer or performance required test. Specifically is voice assistant. And why do we need to SR system? Because speech is the most natural form of communication. It's an effective way to communication between the human and the computer. And speech recognition